In the previous lessons, we learned how to dispatch events from versioned aggregates, store events in the event store, subscribe to events using collection watchers, deserialize events and push them onto the event bus, and lastly, listen to events from the event bus and update the read side database accordingly. While what we've accomplished so far is amazing and we have really made a lot of progress, we're still missing one important piece of the puzzle. How can we make updates to our existing aggregates? We can't retrieve their read model representation from the eventually consistent read side database because, as we know, it's not guaranteed to be up to date. We also don't have a dedicated write side database because we're using the event store as our single source of truth. When you're in this situation, this is where the concept of rehydrating aggregates comes into play. The rehydrating aggregates concept is the process of reconstructing an aggregate object by replaying the events that have been previously stored in the event store. When we say hydration, we are referring to the process of populating an object's fields or properties with data from a storage medium. In the context of aggregates, rehydration is the reverse process. It's about taking the stored data and using it to restore the aggregate object to its previous state. The rehydration process is critical for maintaining the consistency and integrity of aggregates in a DDD-driven application. By carefully reconstructing aggregates from their stored state and enforcing domain rules during this process, we ensure that the system remains faithful to the underlying business logic. It's important to note that while rehydration is a central concept in DDD, its implementation details can vary based on the technology stack and the architectural choices made in any specific project. Alright, now that we've gone over some of the high-level concepts, let's get down to business. To begin, let's open up the Mongo Event Store TS file and inject the Event Deserializer class. We'll use this class to deserialize events from the event store. Next up, let's create a new method here called getEventsByStreamID. Inside of this method, let's first retrieve all of the events from the event store, and then filter them by stream ID, and then sort them by their position. Next, let's check if there are any events corresponding to the provided stream ID, and if not, let's make sure to throw an exception. Lastly, let's deserialize the events and return them. Great! Now, let's create a new application directory inside of the shared folder. Inside this directory, let's create another folder called ports. Here, we'll create a new file called eventstore.ts, and then let's add the following code. This port will be used to abstract the event store implementation details away from the application layer. Back to our Mongo Event Store TS file, let's make this class implement the event store port. Let's save our changes, navigate to the shared infrastructure module TS file, and let's register the event store port using an existing Mongo Event Store provider. And let's not forget to export the event store port as well. Great. With this in place, let's head over to the aggregate root TS file and let's declare a new method called loadFromHistory. The parent aggregate root class already has a loadFromHistory method, but it expects an array of domain events, not objects following our custom serializable event shape. What the function does here is that it iterates over the provided events and applies them to the aggregate object one by one using the apply method. The apply method invokes the corresponding event handler method on the aggregate object, which in turn updates the aggregate state. It also determines which event handler method to invoke based on the event's type. We'll see how all of this works in just a second. Also, notice that it does not set the aggregate version, which is something we need to do manually here. As an additional note, we assume here that events are sorted by their position in ascending order, So make sure that that is the case for your application too if you want to use this code. You may need to have it handled differently. Let's save our changes, navigate to the Shared Application folder, and let's create a new file there called aggregaterehydrator.ts. Here, let's add the following code. We'll need the event store port to retrieve events from the event store and the event publisher to merge the aggregate object with the event bus. Next, let's create a new method called rehydrate, and let's break it down line by line. First, we retrieve all the events for a given aggregate from the event store. Next, we merge the aggregate class with the event publisher so that we can dispatch events from objects of this class. Then, we create a new instance of the aggregate and pass the aggregate ID to its constructor. Lastly, we load the aggregate from history using the method we've just created and then return it. Alright, great. So let's save our changes and head over to the shared module TS file. Here, let's register the aggregate rehydrator class as a provider, and also, once again, let's not forget to export it. Perfect. We now have all the building blocks in place, so let's put them to good use. But before we can do that, we need to first expose a new endpoint from our API that lets us operate on an existing alarm. Let's open up the alarms controller TS file, and let's add a new endpoint called patch alarms:ID/acknowledge. This endpoint will be used to acknowledge an existing alarm. For example, when a supervisor confirms that an alarm is valid and has been investigated. Let's save our changes, head over to the commands folder, and let's create a new file there called acknowledgealarm.command.ts. Here, let's add the following code. With this in place, let's open up the alarm service TS file, and let's add the missing acknowledge method there. This acknowledge method will be used to dispatch the acknowledge alarm command to the command bus. Now, before we move on to the command handler part, let's switch to our domain layer and let's add a new alarm acknowledged event. Note that here we're using the auto-wired event decorator to auto-wire the event class. Next, let's open up the alarm aggregate and let's update the existing acknowledge method to dispatch the alarm acknowledged event. In this method, we simply apply the alarm acknowledged event to the aggregate. Okay, so let's stop here for a quick moment. Where's the logic that actually acknowledges the alarm? Well, we don't have it yet, and that's something we'll implement right now. As we mentioned in the previous lessons, the apply method invokes the corresponding event handler method on the aggregate object, which in turn updates the aggregate state. So, let's add a new event handler method called onAlarmAcknowledge to create that very method. To make it even more type safe, we can use the following technique. Now, if we updated the event class name, the corresponding event handler method name would be updated automatically as well. Before we move on, there's one missing handler we should add here as well. Above the onAlarmAcknowledged event method, let's add the following handler. This event handler will be executed by the loadFromHistory method when we rehydrate the aggregate from history. We're all set in this file for now. But we need to do a few more things in some other files to make everything work as expected. So let's navigate to the alarm severity and let's add a missing toJSON method. Great. Now, if we go back to our alarm, we can see that the error is gone. Excellent. With our aggregate updated, let's navigate to the commands folder in the application layer, and alongside the acknowledge alarm command TS file, let's create another file there called acknowledgealarm.command-handler.ts. Here, let's add the following code. For now, we're just logging the command and that's it, so let's improve that. Using the aggregate rehydrator dependency, let's rehydrate the alarm aggregate based on the command's alarm ID property. Next up, let's acknowledge the alarm. Next, let's call commit to publish events to the event stream. And finally, let's return the alarm instance. Great. Let's save our changes and head over to the alarms module TS file. Here, let's register the acknowledge alarm command handler class as a provider. Last but not least, we'll need a corresponding event handler to update the read model. So let's create a new alarm acknowledge event handler file in the event handlers folder, and let's add our usual boilerplate code. Inside of the handle method, let's use the upsert materialized alarm repository dependency to update the read model. Excellent. Before we test everything out, let's make sure we register the alarm acknowledged event handler class as a provider in the alarms module TS file. While here, let's also update the alarm created event handler, since it now might be erroring out due to the newly added toJSON method in the alarm severity value object we added a moment ago. Alright, and that's it. With everything we've done in place, let's give it a try. So let's head over to our terminal and make sure that our application is up and running. Since there are no errors, let's open up a separate terminal window and let's retrieve the list of alarms. Let's grab one of them by their alarm ID and let's acknowledge it, curling alarms / the ID we copied. And make sure that we do a patch request to hit that new endpoint we just created a moment ago. Fantastic, no errors. Let's switch over to the other terminal window and verify if there are any errors there. Perfect, no errors here as well. We're on a roll. Also, we can see here that both acknowledge alarm command handler and alarm acknowledged event handler providers were executed. Just to double check, let's retrieve that list of alarms again. And there we go. We can see that the alarm has actually been acknowledged. Our code works. If we look, the isAcknowledged property has been set to true for the given alarm. We did it. So, we covered quite a lot in this lesson, but we managed to successfully give our application the ability for rehydration, allowing us to actually make updates to our existing aggregates. Great work if you've been following along and have your application locally as well. There might be some minor nuances, as we mentioned earlier in this lesson, for your specific application's use cases, but the majority of everything we've done here can be used for most any system.